right? That's the gist of why we have them. So the type that we're going to talk about this morning is called correlational research. Correlational research. Does anybody know what it means if I say something, there was a high correlation between two things, what that means?
It's not a direct link between the two of them, but it has a lot in common.
They have a lot in common, right? So I think we talked about like smoking and lung cancer, high correlation, right? So the likelihood, I guess, that a person who smokes a lot of cigarettes might have lung cancer is high. There's a high correlation, a relationship, okay? So correlation is the relationship, the strength, really. Well, a correlation is a relationship between two variables. Let's start with that. It tells you the relationship between two variables okay. So it does that through a sort of long and complicated mathematical equation that you guys don't have to know, luckily. All you have to know is what's called R, and this is a lowercase r. R is what's called the correlation coefficient. And R, small r, tells you the strength of the relationship between the variables. So they could be strongly correlated, weakly correlated. They could have no relationship, no correlation. And that's what we're going to know from the value of R, from that correlation coefficient. So the reason that we want to know this, the reason that we would do correlational research, one reason, it helps us find out information about variables that can't be examined by other methods, like we can't ethically make people smoke cigarettes to see if they get lung cancer, right? It also helps us assess, since we're assessing the relationship between two variables, it can give us an idea of how well one variable might affect or predict the other, right? And prediction is one of the 4 goals of psychology, right? Describe, explain, predict, and change. So it helps us meet one of those 4 goals by having a better understanding of how well one variable, say X, might predict or might affect another variable like Y. When we're doing correlational research, we need to look at 2 variables and we're going to see what the strength of the relationship, if any, might be between them. So, 2 variables that we can look at. Let's do our hypothesis for this experiment can be that people that consume higher number of calories tend to weigh more. Does that sound like a pretty straightforward one? Yeah? Okay. So, what are we going to do to run this experiment? What data are we going to collect? Right? We need to know the calories, caloric intake, and what's the other variable we need to know?
Weight.
The weight. Okay, so we're going to run our study, we're going to take 100 people, and we are going to look at their caloric intake, and we're going to look at their weight. Make sense? Okay, So we're gonna have, say, 200 pieces of information by the time, if we have 100 people, we're getting 2 variables on each person. The way we're gonna organize this information is on what's called a scatter plot graph. You guys are familiar with basic graphing techniques, right? Okay. So if we have 0 here, this is weight we've got on this axis. So you're going to go from 0 to say 400 pounds here, and on the caloric intake 0 to, I don't know, 3,000, something like that. Okay. And you guys would all understand how to plot these numbers, right? Anybody that wouldn't? Okay, so say subject 1, they're one of my bigger subjects. Okay, so their caloric intake was like 2,900 and they weighed like 300 pounds. Where on this graph would that information go? Top right. That makes sense to people? Somewhere up here? Okay, right, because high weight, high calories. Now, subject number 2 is one of my smaller people. They weigh maybe 100 pounds and their caloric intake is like 1,200. So where are they gonna go? Ish. This is a ish, guys. Say there's 4 quadrants. Top left, top right, bottom right. Bottom left? Yeah, okay. Somewhere down here. Now that's not really to scale. Don't worry too much about that right now. Okay. So we understand what we're doing, right? So we're talking about 100 people all over the map. So, since we think, our hypothesis is that there's a correlation, right? We do think that there's a relationship between caloric intake and weight. Our numbers are going to roughly follow some sort of pattern. Okay, it's not a perfect correlation, it's not like everywhere, but there's a grouping, right? And then there's going to be a couple people that don't seem to make sense, people that eat a lot and don't weigh a lot, and vice versa. So if there were 100 little squiggles up here, these would be the people that we gathered data on. Are you guys with me so far? Okay. And since this is 2 variables that we think do have a pretty good correlation, there's some sort of grouping around that central axis, right? So if we took and sort of tried to group most of our data could fall within some sort of central grouping, right? We're always going to have some outliers. You guys with me so far? Okay. So when we're looking at the data, we know that an increase in X is correlated to, is it an increase or decrease in Y? Increase, okay. So both variables are going in the same direction. So, I'm gonna know that my correlation coefficient, or my little r, I have a choice. It can go anywhere from -1 to +1. Okay, r can fall between -1 and +1. +1, or a positive r value, means that there is a positive correlation between variables. Now when you're multiplying 2 figures, x and y, what do you need to multiply to get a positive number? 2 positives or 2 negatives. Okay. So to get a positive correlation, your variables need to be going in the same direction. So either an increase in calories causes an increase in weight, or a decrease in calories causes a decrease in weight. Okay, either way, our variables are going in the same direction. Do we agree? So multiplying these variables would give us a positive number in either case. Do we agree on that also? Okay. So we know we're going to have a positive number. 1 is perfect. 1 means that there's an absolute perfect correlation. Are we going to get perfection? No. And we know in this case we don't. We can see our outliers, right? So, does it look like, though, a pretty good, strong relationship? Yeah? Who thinks yes? Okay. So I'm going to guess here, and here's the thing, guys. Since we're not running the numbers for real, this is a rough estimate, right? We're going to say maybe it's a correlation of 0.8. 0.8 would be a strong, positive correlation. Now, if we had numbers all over the board, does it look now like there's much of a relationship between our variables? What do you guys think? No? Okay. If there was 0 relationship between the variables, what would R be? That's where it gets tricky, right? R would be 0. 0 is no relationship. So if 0 is no relationship, what would it be, maybe, if I take out some of these outliers? But my relationship to the central axis is going to turn into more of a blob, I guess. Somebody just put a guess out. What kind of number might we be looking at here? It's still a positive relationship. There is a relationship, so it's not 0.
Like 0.2.
0.2 or something? Who said that? Yeah? Okay. All right, so something like 0.2 I would call a weak positive. Now, something like this is going to be on quizzes and tests. I promise you, I'm not going to ask you if this is a 0.2 or a 0.3. Is there any way that you can know that without running numbers? No. Okay. So you need to know if it's very weak or very strong. But it's not going to be like 0.2 or 0.3. It's going to be like 0.2 or 0.8 or 0.9. Does that make sense? Yeah? Okay. So those are positive relationships. Now, we could also have negative, right? Because we've got those all those values between 0 and -1 that we haven't addressed yet. In a negative relationship, what kind of numbers do we have to multiply by to get a negative? A positive and a negative. So instead of both of our variables going in the same direction, we're going to have the kind of relationship whereas one variable increases, the other variable does what?
Decreases.
Okay? That's going to give us something in here, some sort of negative relationship. Somebody think of 2 things that might have a negative or an inverse relationship.
More hours of exercising equals a decrease in weight.
Great. All right, so our variables will be hours of exercise. And weight. So this kind of line on an axis shows us an inverse or negative relationship, right? Okay. So, as hours of exercise increases, what's our hypothesis going to be? What's our weight going to do? Decrease. Okay. So, we think there's a pretty good relationship there. What kind of number might we guess this relationship is? Negative 0.8, that's a good one. So negative 0.8 would be a strong negative. You guys with me? Okay. What are two things that might have a relationship of 0? Okay, raise your hand if you prefer chocolate ice cream or chocolate-based things. Raise your hand if you prefer like vanilla-based things. Okay. Do we think that your ice cream preferences and your height have anything to do with each other? No. Okay, so what kind of number would we look at there? Maybe a 0. Maybe if we did enough people, we might find some weird relationship of like a, 0.1 or something, right? Okay. I know this is a little bit of a tricky one. Do you guys have questions? All right. If I gave you a for instance, say I am interested in how to make money off, what are like the lunch vendors say that come here, right? So I want to know what products to sell or what products are going to sell best. So I'm going to study those. And I notice that as outside air temperature goes up, the consumption of cold drinks, like sodas and water, goes up, right? What kind of relationship is that? As air temperature increases, the sales of cold drinks would increase, a positive, okay? And what about, I notice that as outside air temperatures decrease, as it gets colder, the sales of coffee and hot chocolate and tea increase. Right, that's a negative relationship. In this instance, is negative a bad thing? No, it just shows you the direction of the relationship. So that tells me that in the warmer months, I'd want to sell more or stock more cold drinks, and in the colder months, I'd want to stock more hot drinks, right? And that would be a pretty straightforward way of measuring those relationships and trying to figure out what it is that we wanted to do. Okay, so that's something with correlational research. Another time it's very useful. Did we talk about like birth defects in alcohol? Okay, say I'm interested in studying the effects of alcohol on a fetus, right? So, and what kind of birth defects could be caused. In order to run that study experimentally, I'd have to have a control group and an experimental group. The control group would be pregnant women. The experimental group would be pregnant women. They'd have everything the same, all, diet, healthcare, everything else the same, except the experimental group would do what? Drink alcohol. So I can't ethically do that, right? And then I would look at the incidences of what? What would be the other variable? Birth defects, right? So the amount, say, of alcohol consumed and the number of birth defects would be my two variables. One would predict, based on our general knowledge, what kind of relationship between the two. As more alcohol is consumed during pregnancy, what do you think about the incidence of birth defects? Increases. Would probably increase, right? We can't run that experimentally, so we need to do a correlational experiment on that. So I would take 100 women, 50 of whom had some alcohol to drink, some to much, I guess, little to a lot during pregnancy, and some who hadn't. And I would ask them all how much they'd had to drink, and assuming we're getting honest answers here, right? And then I would look at the number of birth defects in the children, and I would come up with a correlation. Okay, so it's sort of an after the fact look at the relationship, but it would give me an idea of just how strong that relationship was between the amount of alcohol consumed and the number of birth defects. Okay, so it works in an instance where I can't run an experimental study. Okay. All right, so what we're going to do now is we're going to break up into groups of 2 or 3, whatever I can do it if you guys want. I'm assuming you probably prefer to do it yourselves. And we are going to come up with a hypothesis. The hypothesis could be, and I mean, you know, we talked about several today, right? We think you'll sell more hot drinks in cold weather. We think there's more birth defects with people that consume alcohol. You can't use one of the ones that we've just used, but come up with any kind of hypothesis that you want. And then I want you to tell me what type of all those research designs that we've talked about, what type you would use and why. Okay, so we're going to create a hypothesis. You're going to choose a research design. Tell me why you chose it. And then I want you to tell me any factors that could affect it. Like, let's think of an example. We talked about naturalistic observation and the fact that since you have no control, you might not get a lot of people the day you're studying or something like that, okay? So sort of the pros and cons and factors that might come into play. So factors that could affect it, and then pros and cons of that particular design in general. This is going to be worth 3 homework grades for everybody in the group. You're going to have the rest of class today, and we're going to have part of class tomorrow, Wednesday rather, to work on it. Okay, it can be handwritten, and make sure, one piece of paper to turn in is fine with everybody's name on it. So why don't you guys go ahead and get into groups of 2 or 3 people. You can do 4 people if that absolutely has to happen, and get started.